Okay, problem 2009, differential equation. So in this problem, we are given the differential equation, dy dx equals 6x squared minus x squared times y. This is let y equal f of x be a particular solution to this differential equation with the initial condition f of negative 1 equals 2. Part A, use Euler's method with two steps of equal size starting at x equals negative 1 to approximate f of 0. Okay, so we will set up our Euler's method table. So that's where we have 5 columns, x, y, y prime, delta x, and delta y, which is equal to y prime times delta x. Now we're going to fill in all the information that's given to us. We start at the point negative 1, 2, and we want to get to the point where we're approximating f of 0 with 2 steps. So we want our final x to be 0, and this is the y value that we're looking for. To do that in 2 steps, we need to have this intermediate step of negative 0.5. That means we're increasing the x's by 0.5, so our delta x is 0.5. Now we can start filling the table in based on the differential equation. So what we'll do is we'll find dy dx at the point negative 1 comma 2. So that means I'm going to plug in negative 1 for x and 2 for y. So that will get us 6 times negative 1 squared minus negative 1 squared times 2, which is 6 minus 2, which gives us a value of 4. So y prime is 4. Then I take that y prime, multiply it by delta x. And my delta y is 2, so now I'm going to add 2 to my previous y value to get a 4. And now I start the process over again. So now I'll do the derivative at the point negative 0.5 comma 4. So that'll be 6 times negative 0.5 squared minus negative 0.5 squared times 4. Now negative 0.5 squared is 0.25, so this is actually going to be equal to 6 times 0.25 minus 0.25 times 4. 6 times 1/4 is 1.5 minus 1, which gives us 0.5. So I'll put a 0.5 here. And I'll do 0.5 times 0.5, which is 0.25. 0.25 then gets added to 4, which would be 4.25. So we can say our approximation, f of 0, is approximately equal to 4.25, or if you're a fan of fractions, that would be 17 over 4. This would be a 2-point solution, 1 point for the work, 1 point for the approximation. Question B. At the point negative 1, 2, the value of the second derivative is equal to negative 12. Find the second degree Taylor polynomial for f about x equals negative 1. If we're going to do a second degree Taylor polynomial for f about x equals negative 1, the general form of this second degree would be f of negative 1 plus f prime of negative 1 times x plus 1 plus f double prime at negative 1 over 2 factorial times x plus 1 squared. We have a plus 1 because our center is a negative, so it's x minus negative 1, which gives us a plus 1. Now the rest of these values we actually know. So f of negative 1, this value is given to us. That is our initial condition of 2. F prime of 1 was the first derivative we got when we did our Euler's method. So this is actually the same thing as our first derivative when we plug in negative 1 and 2. We got a value of 4 for that in our first step of Euler's method. So I'm going to replace that with a 4. And then this second derivative Well, that's what they give us in this problem. This is equal to the second derivative at the point negative 1, 2, and we know that that's equal to 12. Oh, negative 12, excuse me. So we'll do negative 12 over 2 factorial times x plus 1 squared. If we wanted to simplify that, we can. Otherwise, we could leave it as this. And this is all that work for 1 point. So it would be all or nothing for this one. Now, 2 points for part A, 1 point for part B. That leaves 6 points for part C. Part C is looking for a particular solution to the given differential equation with the initial condition f of negative 1 equals 2. When we're asked for a particular solution and we are given dy dx as a function of x and y, this is an indication that we need separation of variables. So we'll start this problem by separating the variables. But before we do that, we need to rewrite our derivative, which is 6x squared minus x squared times y, as a product of two functions. Okay, so I'll write this here. We need a product. Right now, we have a difference. We need to rewrite it as a product. So we want to think about what we could factor out to rewrite it. This can be rewritten as x squared times 6 minus y. This is a product. This can be separated. So what I'm going to do is I'm going to take the 6 minus y and move it with the dy, and I'm going to move the dx with the x squared. So I'll have x squared times dx and dy over 6 minus y. This step, this separation right here, is our first point out of the 6 for this problem. Our next step will be to integrate both sides. Okay, so we'll do the antiderivative of both sides. Now the right side, way easier. That's just going to be x cubed over 3 plus c. On the left side, we've got this minus y in the denominator. So when we just have a y to the first power, we know our antiderivative is going to involve a natural log. But since we have a negative y, we've got to take care of that by multiplying by a negative on the outside. This becomes our antiderivative. Each antiderivative is a point, and our plus c is a point. We're already at 4 out of 6. Okay, so our last couple steps, we need to solve for y, and then we're going to actually find c based on our initial condition. So our next step here would be to start getting y by itself. So I think what I would do next is I would try to isolate the y. I'm actually going to move the negative over to the right side. So we end up with positive ln of 6 minus y equals negative x cubed plus 3. And I don't need to move that negative to the c. The c's will come out to be what it is in the end. Now I want to get rid of the ln, so I'm going to do e to the power of both sides. This leaves me with 6 minus y equals, let's see if you guys remember this, when we do e to the power of both of these, it's e to the power of the negative x cubed over 3 times e to the c, which just brings out a c times e to the negative x cubed over 3. And now we still just need to rework this. What I might be inclined to do is I might be inclined to add y to one side and subtract all of this. So I would get y equals 6 minus c times e to the negative x cubed over 3. And now comes time to solve for c. So put this work up here. So now we'll plug in our point, and our point is -1, 2. So I'm going to plug in the -1 for x and the 2 for y. So 2 equals 6 minus our c value times e to be negative times -1 cubed over 3. And now I have to solve this for c. So, simplifying this, we get 2 is equal to 6 minus c times e. -1 cubed is a -1. Make another negative, I've got a positive 1/3 from that. Subtract the 6, we get -4 equals c times e to the 1/3. Divide by e to the 1/3, and I get c is equal to -4 divided by e to the 1/3. That seems super weird, but that is our c value for this. So we can now rewrite our final answer as y equals 6 minus 4 over e to the 1/3 times e to the -x cubed over 3. For those of you that just check the answer key, if you've also checked the answer key, this is an equivalent answer to the one in the answer key, but it is in a different form. But this would also work. We could make it look a little prettier, but this will get the job done. So if we end up with this, solving for c, solving for y, those are our last 2 points for a total of 6.